To, the first part is graphing and inequality. Okay? It's going to have multiple sections as well. Could be a system. The key things, we're going to go over some stuff. Yeah, buddy. Okay. My goal is just maybe go through some of these and go from there. Yeah, I like it. Okay, here we go. So, let's go ahead and start by graphing a circle. How many guys remember circles from 1010 where we have this equation? Equals our radius squared. Do you guys remember that? Where HK is our center and R is our radius. Yes, everybody remember that? Okay. So with our case, what's our center? 0, 0, right? Because notice it's not being shifted left or right with any of the x's, correct? Or the y's. So I'm at 0, 0. But then r squared is 25, correct? Because r squared is 25, r is what? 5. Okay, I'm going to grab another color here. So we know it touches all of these points. Okay, how many of you guys remember, because it is a less than and not an equal to, that becomes a dashed line because the line of the circle does not work, right? So if you pick any point on the circle, that will not work because the circle is not less than the radius, right? The circle is the radius all the way around. Does everybody understand what I mean by that? So therefore, this is a great circle, by the way. Especially that little hump area right there. Okay, so that is my circle. Now, when you have an inequality, there's an infinite amount of solutions. Always. Because I can plug in many values for x and y that make that work. Right? Okay, how do I tell? Well, I know other teachers always know how to tell by just the freaking less than sign. I got my butt kicked when I did that stuff. So I say screw to that. Okay, what I do is I pick a point, any point in the world, as long as it's not on the circle or on the line or whatever it might be. Does that make sense? So I'm going to pick the point 0, 0, because that's not on the circle, is it? Okay, so I go plug it in. 0 squared is 0. My y value was 0. 0 squared is 0 again. Is that less than 25? Is that a true or a false statement? That is a true statement, isn't it? 0 is less than 25. Because that is a true statement, I'm going to shade where that point is. Okay? So therefore, that point is within the circle, so I'm going to shade in here. Does everybody understand how I did that? Okay, just to prove another case, what's another point that's outside of the circle? How about the point 6, 0? It's right here, right? That's outside the circle. So I'm going to show you what it looks like if it was a false statement, because this should come out false. So 6 squared is 36. And then notice this point was 0, so I'm going to plug 0 in for y. 0 squared, 0. Is that less than 25? That is a false statement, right? Because it was false, what do you guys think I would do? I would shade the opposite region. If I was on the outside, I shade the inside. If I was in the inside, I'd shade the outside. Does that make sense to everybody what I mean by that? Okay. Any questions there? Yes, Greg. So yeah, so what I'm saying is though, see this point would be 6, 0 right here, right, Greg? So notice the only thing we have is outside the circle or inside the circle. So because I picked 6, 0 and that was false, I would have to shade the other region. So therefore, that's why I would also be shading on the inside here. Does that answer your question? Okay. Everybody good? Did we do this in 1010? Maybe not with circles and stuff, but I think we did the shading with inequalities. Okay. All right. So now we're going to go ahead and do one that's a system of inequalities. Okay, a system of inequalities. Excuse me. Really quick, guys, I'm going to grab something. I want to get a plane. Just so I can make it spiffier. That one looks good. We'll go ahead and copy that. Nope, that one's not big enough. All right, so we'll make him a little bit bigger. Everybody good with that? All right, here we go. So what we're going to do now is we just have this time, we have 2 items that we need to do. Because it's a system, we are looking for where both parts are shaded. Does that make sense? So where do they share of their shading? Do they always have to share shading areas? No, if they don't, that's a no solution. Does that make sense? If they don't have any common shading areas, that is a no solution. But these guys do. Okay, so once again, what's this top figure? It's a circle. What's our center again? 0, 0 with a radius of 5. Okay, is this a dashed or a solid line this time? Solid because of the greater than or equal to, right? Does that make sense to everybody? That's so damn pretty. Okay, there's my circle. Okay, I personally am going to wait for just 30 seconds until I graph the other portion as well. Okay, I'm going to graph the other line. The other one is a line. Now either A, I could solve for Y and do a slope intercept, right? Start at my intercept, do my slope, whatever it might be, correct? Or I could go ahead and do graphing via my intercepts, which I have an x-intercept and a y-intercept. What is the definition of an x-intercept? That's when y is 0. So therefore, when y is 0, okay, I'd have x equals 5. Does everybody see that? By plugging 0 in for y, 2 times 0 would be 0, right? So therefore, x equals 5. Do I care about the equal to right now? That's just for shading. I always treat it like an equal sign until I come to the shading portion. Is everybody good? Understand what I'm talking about there? Okay, so there it is. Pretty as hell right there. Sorry, I gotta quit swearing. I'm in a mood. Maybe I should suck on a root beer barrel. It'd help. Okay. Now, what's my y-intercept? That's when x is 0, right? So 2y equals 5. Y is 5/2. Yes, no? So 5/2, that's 2.5 right there. Okay? And then what do I do there? Just needs to be a line, doesn't it? Okay, I'm going to try my best here. Is it solid or dotted? Solid. Once again, please bear with me on my graphs here today. It's a little bit harder when you're using your finger. Okay, so it intersects it, right? And we did previously graphing intersections of nonlinear equations, didn't we? Okay, that was that 10.8 section we did with 10.1. Now I need to come back and shade, okay? So I'm going to work on the top. I'm going to work on the circle. What's a point on the circle that's really nice that doesn't go through it? If I can, I like to use 0, 0. Okay, so when I plug it in, I get 0 squared plus 0 squared. Is that less than 25? True or false? True. So therefore, I shade within where that point is. So it's on the inside of my circle. Does everybody get that? Yes, no? What's another nice point for the line that it doesn't go through? You may not use it if it goes through it. 0, 0 again works, doesn't it? Okay, so I plug it in. Is 0 plus 0 greater than or equal to 5? Is that true or false? False. So because that is a false statement, okay, I'm going to shade here 0, 0, so I'm going to shade the opposite side. So I'm shading this side. Would you guys agree? So where do they share? Inside the circle, but above the line. And that would be right here. I'm going to highlight it just to make it a little bit easier. That's this region right in there, huh? That region, I don't know if is that better with the purple. The shaded purple region would be where they share. So any point within that solution area would be our solution. Okay? Any questions on that? Yes. The one, you could redraw it again and just show that area as a shaded region. Just make sure that you distinctly show which region has both. Nope, that is your answer. This graph right here is my answer. When you're doing a system of inequalities, a graph is your answer. Is that what you were looking for on the answer? Okay. So sometimes, okay, here we go. A little bit smaller. So this time we have 4 spots. We have 4 equations. Okay. So our goal is to make sure we find the region that works for every single one of these. So here we go. X plus 3y is less than or equal to 12. Okay, once again, I'm going to graph by my intercepts. Okay, whenever they're in standard form, I like to graph by my intercepts. So what I go ahead and do is I plug 0 in for x. That's my y-intercept. So if I plug 0 in for x, what will be my y-intercept? 3y equals 12, so therefore it is 4. You guys understand how I found 4? I plug 0 in for x right here. So 1, 2, 3, 4. Okay, we're going to designate this one by the red line. What would be my x-intercept is when I plug 0 in for y. So I plug a 0 here. X is 12. Need 2 more tick marks. X is 12. Okay? You just all of a sudden like, what? Okay, so this is this line. Now, once again, trying to do my best, but bear with me. I'm doing it by hand. Woo! That's lovely, huh? Alex is back there like, psh, that's child's play. Okay. Now, I'm going to go ahead and graph this fella. My x and y intercept, if I plug 0 in it, they're both going to be 8, aren't they? So that's right here. Whee! That's so damn pretty. Does anybody have a question there? Now, the next thing I have is x has to be greater than 0. So notice here's x equals 0, this line right here, this purple line. Because that's x is 0, right? And then, let's not do that color. I wonder if the orange shows up. Here is y equals 0. Okay? So we're looking for the region that shares every single one of those items. Okay? So with that being the case, let's start with the green one. What's a nice point for basically every single one of those except for x is greater than 0 and y is greater than 0? 0, 0 works. Okay, if I plug it in as 0 plus 0 less than or equal to 12, is that a true statement? Yes, so here's 0, 0, right? So I'm going to shade the side of that point because it's true. So I'm going to shade this side. And I just do this little line right now because I don't want to hurry. Sometimes if you shade really crazy, it gets all messy. So I'm just trying to keep it nice, and then we're going to shade the region that they all have in common. Is everybody with me on that? Okay. The next one, 0, 0 still works. Okay, and that was the red one, I believe. Oh, nuts and crackers, it wasn't. Control Z. Oh yeah, it'll be all right. By the way, the red one was this. I should have graphed this one. I did the green one, but that was the... Okay, now with the green one, this was the green one, by the way. Okay, if I plug 0, 0 into that, is it a true statement? So it's still shaded below, isn't it? Right? So far, this part that's shaded is in right here. Okay, it has to be less than this line and less than this line, so I'd be right here, isn't it? Correct? But I also have to say who's greater than 0. This side, right? Who's greater than y? Up. So where do they all share? So get my highlighter here. This region right here is everything they share. That would be the answer. Okay. How many of you guys remember doing this sometime in your past previous learning? Awesome. Okay, the only other thing I really want to share with you is how do we graph a parabola? Okay, so let's see if we have it here. All right. Fun times. Okay, what's the top equation? What kind of equation is that? It is a circle again. All right, where's our center? 0, 0 with the radius of 3. So here it is. I wonder if my circle thing is going to work. I'm going to try it. Oh, that's not what I wanted. Undo. Okay, I tried. I was going to make it all pretty for you. I know. All right, just because you asked. Oh. Negative 3, 3? Hold on. I'm going to expand him. Negative 3, 3. Right there. I know, right there. Oh my goodness, look at you. You're so good. And technically, guys, that's graphed right as well, except it needs to be dotted instead of a solid line. Does that make sense? I just wanted to make it a pretty picture for you guys. Does everybody got that? Understand where that's coming from? So that actually is shaded correctly as well. Okay, because notice it is less than 0, 0 is less than 9. That's a true statement, so I would be shading that region, right? Cool. Okay, so now this guy, if you guys will recall, this guy right here is y squared is greater than or equal to negative 2x plus 1. Does anybody remember what? Oh, I should do it this way. Let's not do that. Let's get rid of that. Undo, undo, undo. You always want to solve for the thing that's not. So therefore, I'm going to go ahead and have y squared minus 1 divided by negative 2 is less than or equal to x. I just solved for x here. So does anybody remember what kind of parabola this is? Is this our normal up and down parabolas? Do you see how y squared is being squared? Y is being squared, so it's one of these guys. Does that, you guys remember that? Yes, no? Okay, so with that being the case, let's plug in some points just to graph this very nicely. Okay, so I'm going to plug 0 in. 0 squared is 0. 0 minus 1, negative 1, over negative 2 is 0 is a half. So I come over to 0, and I'm up a half. Now I can plug in 1 for whoa, flipper flop. That was vice versa. I plugged 0 in for y, I got a half. So it should be here. All right, let's go ahead and plug in 1 for y. 1 squared, 1, 1 minus 1, 0. So therefore it's up here. Maybe that's a little high, but that works. Let's plug in negative 1. I also get 0. So it kind of has this shape. That's horrible. But you get the idea. It's a parabola on the side. If you guys want to plug in 2, we can do it. And so forth. But it is a parabola on the side. Okay? Now, let's pick a point. Can I use 0, 0 is kind of hard to tell, isn't it? Because I have that other shading on there already. So I'm going to pick another point. I'm going to pick a very distinct point. I'm going to plug 0, 10. Here's my point, 0, 10. Okay, and then these extend on like such. Okay, so I'm going to plug 10 in for y, 0 for x. So 10 squared is 100. 100 minus 1 is 99. Divided by -2, is that less than 0? Is that true or false? It's true, isn't it? Right? So therefore, I'm going to use the highlighter again and do it with this yellow. That means my shaded region is out here. So where do they share? It has to be inside the circle but outside of the parabola. So where they share is the Pac-Man looking part. Is everybody okay with that? Any questions on that? Okay. Howdy doody. Yeah? Hey, tomorrow's the big day. Free MLB package. Are you using your daughter's or am I getting it? Is your daughter still on T-Mobile? Okay. I think I have 4, so should be able to. Okay. Yeah. Tomorrow's when it comes out that I can get it, so. Exactly. Okay, basically, guys, that's the 10-9 right there. That's just 10-9. I'll give you guys that homework in just a moment. But now, that other packet that I gave you, that's linear programming. Okay? Examples out of that, guys. So this one, problem. Okay, we're usually going to be solving problems. I can show you when it's. Okay, let's go ahead and. Wow, that was a quick one. Let's look at number 3. We're gonna maybe yeah, sure. We'll start. Look at number 3. So our equations are x is greater than or equal to 0, y is greater than or equal to 0. So basically, what quadrant does that put me in? Quadrant 1, right? Does everybody get that? Yes, yes? No, no? Feel good with that? Okay, then we have 2x plus y is less than or equal to 10, and 2x plus 4y is less than or equal to 28. So, we're going to go ahead and graph this. This is an answer solution. It's not, the solution is not necessarily the graphing portion. I'll show you in just a moment. Okay, so with what I have here, let's go ahead and start graphing this guy as a blue line. Once again, because they're in standard form, I like to graph via my intercepts. Okay, I like to graph via my intercepts. So the x-intercept is when y is 0. So if I plug 0 in here, x would be 5, wouldn't it? because I divide that 2 over, x would be 5. Does anybody have a question on how I'm finding these intercepts? Britt, you good? Everybody good? I know I'm not showing work very much on it. That's why I want to make sure. So x is 5. 1, 2, 3, 4, 5. So I have that dot. My y-intercept is when, notice I plug 0 in for the x, so I'd plug 0 here, so y is 10. So it's all the way up here, should be in blue still. Now, if you have colored pencils on your homework or on your test, it would make it a little nicer for you when you're doing these systems so that you can shade and see where they overlap and things like that, right? Okay, should this be a dashed or a solid line? Solid line. All right, here we go. Woo, that's so dang pretty. That is the best line you guys have seen. Okay, everybody good there? We can hurry and tell where it's shaded right now. Is 0, 0 an option for us? Yes, so I plug it in as 0 plus 0 less than 10. True or false? True, 0 is less than 10, so I would be shading this direction. Everybody there with me? Okay, let's go ahead and do this other one in red. So notice looking for my x-intercepts and my y-intercept. So my x-intercept is when y is 0, so I have 2x equals 28, so that x would be 14. So that'd be 11, 12, 13, 14. Anybody have questions there? What would be the y-intercept of that? I go ahead and plug 0 in for x, it would be 4y is 28, so that would be at 7, wouldn't it? Now, okay, so we're going to finish this up. Oh, not so pretty. Okay, we plug 0, 0 in again. Is that true or false? Is 0 plus 0 less than 28? That's a true statement, correct? Yes? So therefore, we're shading below. Once again, my graph's not very pretty, but I think you get the idea of what's happening, correct? Yes, no, yes, I hope so. Alex, you good? Thank you, Alex. Okay, notice though, we also talked about things being greater than 0. So greater than 0 would be, here's my line of x is 0, here's my line of y is 0. For something to be y greater than 0, I need this side. For something x to be greater than 0, I need this side. So does everybody notice that once again, this right here is my shaded region? Yeah? We all good with that? That is one annoying sound, isn't it? Okay. Now, the part that's different on this one is this is basically what we just taught you, is that part, right? But as you guys will notice, do you guys see that P equation on top? It says P is 140 minus x plus 3y. So I don't know, this is not in the context of a story problem. So therefore, I don't know if that's standing for profit, but I'm pretty sure that's saying profit. What do we usually like to do on profit? We like to maximize our profit, don't we? So therefore, what a linear system of equations or linear programming does is it finds these intersections. So what's this intersection right here? What's that coordinate? 0, 7, right? That's one of our coordinates. Okay, then I want to find this intersection. What's that point? 0, 0, huh? Is everybody with me on that? Okay. Basically, guys, I'm finding the coordinates of all these lines intersecting each other that bounds the region that we shaded. Okay, what's this point right here? That was 5, 0, wasn't it? Okay, and then I need to find this intersection. Now, my graphs kind of sucked. So, can I really find the solution via graphing with mine? Your guys might be able to, because you maybe did a little bit prettier, right? But if you can't see it, because like I've told you in the past, is graphing the best solution by finding that solution? No, because you have to be very accurate, don't you? Okay? So with that being said, I can't find it. So therefore, I need to find where these two intersect. Have we learned how to do the intersection of two equations? Sure. So we're going to quickly do so. I'm going to bring them down here just so I can show you the work. Was that 2x plus y is equal to 10? I know it's a less than, but I can just treat it as an equal sign right now. Is that a correct statement? Okay, what was the other one? 2x plus 4y equal to 28. All right. So we're going to do the system. So notice it's really nice that our x's are aligned, aren't they? So I just need to negate one of those. So I'm going to negate the top one. And so therefore I get 3y equals 18. So my y value is 6. Feel good about that? Okay. Then I have 2x plus 6 by substituting into the top one equals 10. So 2x equals 4. So x is 2. So what's the other intersection point? 2, 6. Now if we look at our graph, that kind of looks like a 2, 6. I mean, I'm not perfect, but it's pretty much there, isn't it? Right? All right. So we have all the coordinates. Now, what linear programming tells us of these coordinates, that will always maximize our data or minimize our data. These points always tell us maximum or minimum when I plug it into an equation. Like if I want to minimize cost, remember, because like maybe you're talking about building something as a project for your company, right? You want to minimize the cost on how much it costs to make the item, right? This would work. Does that make sense? So what I do now is I plug each of these lovely coordinates, okay? I plug each of these coordinates into this equation. So let's plug in 0, 7. So when I plug in 0, 7, 0 for x, 7 for y, I get 140 minus 0 plus 21. So what do I get there? 161. Is everybody with me on that? All I did was plug 0 in for x, 7 in for y. Okay, let's plug in 5, 0. So 5 for x, 0 for y. 140 minus 5 plus 0 is 135. So far, if this was like widgets, two different types of things that you're making, wouldn't you want to maximize your profit by using the 161 so far? Because it would get us more money, wouldn't it? Okay, let's use 0, 0. That's pretty easy. That's going to be 140. Everybody good there? The last one, I'm going to plug 2 in for x, 6 in for y. So 140 minus 2 is 138 plus 18. 138 plus 18. 156. Of those 4 intersections, which one would maximize my profit? 0, 7 would maximize my profit. That, guys, all that work is, that's my answer. That's the one that will maximize my profit. Okay, so you're doing a system of inequalities, but then you're plugging that information into an equation to maximize or minimize whatever it might be. Okay, looks like we have time for one more equation. Anybody want to look through one, and I can go ahead and graph it for you between any of the problems, the story problems. We have furniture, hauling fruit, housing. Let's do the housing one. I think I did that. Let's do that. Number 6. Number 6 on the very front. Okay, so here's what we need to understand. A housing contractor is subdivided a farm into 100 building lots. So we have 100 building lots. That's important. Okay, then it says they have 2 types of homes. They have the colonial and the ranch. Now, I'm not using X and Y because I don't care. I prefer, when I do these, to keep them in their terms of what they are. C and R in my case, right? Just so I don't get confused. Because then I'm like, oh, really, what does this mean? But if I keep it in there, I can understand it a little bit more. So therefore, guys, don't I have my first equation? C plus R has to be less than or equal to 100. Why is it less than or equal to? Well, I have 100 lots, right? Correct? Do I have to use all 100? Can I use any more than 100? No, so it has to be less than or equal to, right? Everybody good there? Okay, the next part it says, a colonial requires $30,000 of capital. So colonial is $30,000 of capital, but it gives me a profit of 4,000. So the profit is 4,000 for that colonial. Whereas the ranch, how much capital does it take? Meaning it takes 40,000 for them to kind of build that lot. Does that make sense? Or build that house. But their profit is larger on that home. That profit is $8,000. Is everybody there with me? Okay, they have a total of $3.6 million in capital. Okay, so that gives us an equation. Because I know that 30,000 of my capital is being built for every colonial house. Does that make sense to everyone? Plus 40,000 of my capital is being built for every ranch style house. But I know that money, I can't go over how much I have. And how much money is that? 3.6 million, which is 3,600,000. Okay? Now, what other 2 equations are there, but they didn't talk to us about? How many, could I have negative colonial houses? So what does colonials have to be? Greater than or equal to 0, right? What does my ranch style houses have to be? Greater than or equal to 0. Is everybody good with me on that? Any questions there? How many of you guys want to really graph this big A freaking equation? Okay, let me show you a little trick. How many zeros do they all share? 4. So I could write this as another way of saying 3C plus 4R is less than or equal to, I'm going to get rid of 4 zeros. 1, 2, 3, 4. Less than or equal to 360. That makes it a little bit nicer, doesn't it? So I'm not so low. Do you guys agree with that? We feel comfortable with that? Okay. So now we have our equations. Now, what do you guys think those other numbers are? That 4,000 and that 8,000. That's going to be part of my profit equation, isn't it? that I'm going to go ahead and plug it back into in the end. Okay, that will help us. What time do we get out of here? 55? I always get puked on Mondays. I got to cut my voice. Pinewood Derby today. I'm excited. Well, he's excited. Whatever, I'll shut up. It works. Yeah, that sucked too. All right. Okay, so ladies and gentlemen, I'm going to graph this. Notice if you look at this blue, or we're going to do that. Oh, that's going to be messy. Let's do that one in blue. Okay, we're going to do that top one in blue. It's C plus R is less than or equal to 100. Okay, each of these tick marks are now going to represent how much? 10, because I don't want to go bigger than that. Does that make sense? I don't want to do 100 tick marks. Is everybody okay with that? Okay, so notice each of those guys. Sorry, you guys are going to help me on this. Okay, each of these guys have an intercept of 10. So that would be 0, 0, 10. There we go. Those are representing 100 each. Come on. There we go. Perfect. Look good? No? What I did is graphed this equation right here. But instead of it being 100, I did each tick mark representing 10. So I guess I could put 100 here. Does that make more sense to you? Sorry about that. Is everybody with me that each increment's worth 10? Okay. Now, how many times for this red equation? Okay, once again, that's 3C plus 4R is less than or equal to 360. I'm going to find my C, where notice this is going to be my C axis and this is going to be my R axis. Because they're not in terms of X or Y, I got to mention which one's which. You guys agree with that? Okay. All right. No, ma'am, it wouldn't. As long as you're consistent with both equations, it's fine. Okay. So, if I go ahead and put 0 in for R, how many houses could I make of Colonial? 360 divided by 3 is 120, correct? So therefore, here's 11, here's 12, here's 120. Anybody have a question there? Yes, no, maybe so. We feel good? Okay. If I plug 0 in for C, I have 4R is less than 360, so R would be 90. So I go ahead and find that right here. Go ahead and graph it. Once again, my graph kind of sucks, but you get the idea of what's going on, don't you? Okay, once again, 0, 0 works for both of those, and it's both going to be shaded below that. Can you guys see how it's going to be shaded below them? But notice, we also have our houses have to be greater than 0 because that makes sense as well. So once again, here is my shaded region. How many times does two lines intersect? They intersect how many times? Once, right? So it might look it hits a couple times, but it's only hitting it once, isn't it? So I got to find that intersection. So once again, I need to look for all locations of the corners. So this corner right here is 0, 0. You guys agree with that? Then we have this point right here, which is 0, 90. And then this point down here was 100, 0. Does everybody understand those locations? We have one more location, don't we? It's where those two lines intersect. Are we good enough just to check it via the visual? It's not. Even if I was up there and I was doing it with a straight line, it wouldn't be pretty enough to do it anyway. Okay, so you're going to have to solve using a system of equations, and that makes sense because that's kind of the unit we're in, right? Okay, so coming back down here, I'm going to go ahead and write it. So I have C plus R equals 100. And then I had 3C plus 4R, I believe, correct? Equaled 360. Is that what they were? What are we going to do? We're going to times the top row by how much? I'm going to go -3. So I get -3C minus 3R equals, -100. So when I get this, I get R is 60. So if I plug that back in up in this equation, my colonials have to equal 40. So if we look at this, does that look like my colonials are, how much should I have for colonials? 4 up 6. There's my intersection point. 40, 60. Okay? So that's kind of what we needed. We did our linear programming. Now what's the equation that we're going to be plugging it into? Well, our profit is we make $4,000 off of every colonial, don't we? 4,000 for every colonial, plus we make 8,000 for every ranch. Yeah? We feel good? So what are we going to do? We're going to take all those points, those intersection points, and plug them in. So if I plug 0, 0, if I don't make any houses at all, my profit's going to be 0, isn't it? Right? If I plug 100 colonials in, okay, that gives me 4 million. That's what my profit would be. I'd make 4 million bucks. Not too bad, huh? Do you see what I did there, Greg? I just plugged 100 in for Z and 0 in for R. Does that make, are you seeing what I'm doing here, guys? Okay, what would be 0.90? It'd be 7,200,000. So far, I'd rather sell 90 ranches and leave 10 lots open, right? Than do 100, oh snap. Okay, anyway, when I plug this guy in, he's going to be the fella that works. If you want to do it on your own, that's what's going to happen. Okay, homework really quick. Okay, on the packet right here, go ahead and do the 5, 7. Let's actually do number 1. And then obviously there's a lot more here. Number 11. Okay, and try any other ones. On the 10-9. Go ahead and do 3 through 45, every other. Okay? For those that are testing next time, be ready. If you have questions, come talk to me, please. Thank you, guys. Sorry about my voice today. Hopefully it worked.